In water supply engineering, Unit 5, Water Distribution System and Supply. In order to fulfill the water requirements for domestic, industrial, and commercial purposes, water has to be distributed from the treatment units to the individual houses. A well-planned distribution system consists of the arrangements of pipelines, valve, hydrant, service connection, service reservoirs, and pumps, etc. The complete arrangements used to distribute the purified water to the consumer is called water distribution system. These are all the contents in this unit. Water distribution requirements, components, functions of water distribution system, drawings of water distribution system, network design, and analysis of distribution network, appurtenance used, leak detection, methods and principles of design of water supply building, house service connection, fixtures and fittings, plumbing system. First, we see what are the requirements of water distribution system. Water distribution system. It is a network of pipeline that distribute water to the consumer. The purpose of distribution system is to deliver water to consumer with appropriate quality, quantity, and pressure. They are designed to satisfy the water required for combination of domestic purpose, commercial, industrial, and firefighting purposes. Requirements of water distribution system. It should have the capacity of supply the water with adequate pressure. It's a good distribution system should satisfy. Pressure should be great enough to meet firefighting needs. Pressure should not be excessive because pressure booster pumps to elevate the water to upper floors. Purity of water for this distribution system watertight. Maintenance should be easy and economical. Water remain breakdown periods during repairs not cause any obstruction to traffic. Layout of distribution system. The distribution pipes are generally laid the road pavements and such as their layouts generally follow the layout of roads. Branching pattern with dead end, grid pattern, ring system, and radial system. It's suitable for first one dead end system or tree system or branching pattern with dead end system. In dead end system, it's suitable for old countries and cities having no definite pattern of roads. In this area, we use this dead end system method. This is having one main line and submain and branches. Main line contains the main sources of water supply. There is no distribution of water to consumers from the main line. Submains. Submain connected to main line and they are along the main roads. Branches connected to submain and they are also along the streets. Service connection connected with branches. Advantages and disadvantages of dead-end system. Advantages of dead-end system is simple method, required dimension of the pipes are economical, less number of cut-off valves. And disadvantages of dead-end system. Repair time, water not supplied until the work is completed. Large number of dead ends, water does not circulate but remain static. Sediment accumulate due to stagnation of dead end. To overcome this, drain walls provided at dead ends, water drain out periodically. Large water is wasted. Firefighting limited since one main line. At the end of the line, pressure low because additional areas connected to the water supply main. Next pattern is grid pattern. All pipes are interconnected with no dead ends. Water can reach any point from more than one direction. It is suitable for cities with rectangular layout where the water remains and branches are laid in rectangles. This is the cross section of grid iron system. This is the M for main pipe and B for branch pipe and S for cut-off valves. Subbelts. Advantages and disadvantages of grid iron system. Advantages of grid pattern. Stagnation does not occur. In case of repair, water can flow from other side. Water reaches all points with minimum head loss. Time of fire by manipulation with cut-off walls, plenty of water. Disadvantages of grid pattern system. Length of the pipe, more cost and also more walls are required. Calculation of pipe size is complicated. Ring system. The supply main is laid all along the peripheral roads and submains submains branch out from the mains. This system also follow the gridiron system with the flow pattern similar in character to that of dead-end system. So determination of the size of pipes is easy. Advantages of ring system. Water can be supplied to any point from at least two directions. Radial system. The area is divided into different zones. The water is pumped into the distribution reservoir kept in the middle of the zone. The supply pipes are laid radially, ending towards the periphery. Radial system advantages. It gives quick service. Calculation of pipe size is easy. Method of distribution system. For efficient distribution system, adequate water pressure required at various points depending upon the level of source, topography of the area, and other local conditions. The water may be forced into distribution system by following this. One is gravity system, pumping system, combined gravity and pumping system. Difference between the gravity system and pumping system. Suitable when source of supply is at sufficient height. Most reliable and most economical distribution system. The water heat available at the consumer is just minimum required. The remaining heat is consumed to the frictional and other losses. Treated water is directly pumped into the distribution main and out storing, also called pumping without storage system. High lift pumps are required. If power supply fails, complete stoppage of water supply. This method is not generally used. Combined gravity and pumping system. This is the most common system. Treated water is pumped and stored in an elevated distribution reservoir, then supplies to consumer by action of gravity. The excess water during low demand periods gets stored in reservoir and gets supplied during high demand periods. Economical, efficient, and reliable system. Distribution reservoir. Reservoir. One is service reservoir, storage reservoir. Storage reservoir store the treated water for supplying water during emergencies. Also to help in absorbing the hourly fluctuations in normal water demand. Functions of distribution reservoirs. Observe hourly variations in demand. Allow water treatment units and pumps to operate at a constant rate. Reduce RMO cost. Help in maintaining constant pressure in distribution system used during emergencies. Increase overall economy by reducing the size of pumps, pipelines, etc. Distribution reservoir location and height of distribution reservoirs should be located as close as possible to the center of demand. Water level in the reservoir must be sufficient elevation to permit gravity flow at an adequate pressure. Types of distribution reservoir is service reservoir and elevated reservoir. Surface reservoir, these also called ground reservoir, mostly circular or rectangular tank. Underground reservoir are preferred especially when the size is large. These reservoirs are constructed on high natural grounds and are usually made of stones, bricks, plain or reinforced cement concrete. Surface reservoir. The side walls are designed to take up the pressure and the water when the reservoir is full and the earth pressure when it is empty. The position of groundwater water table is also considered while designing these reservoirs. The floors of these reservoirs may constructed with RCC slab or square stone blocks resting on columns. To obtain water tightness, bitumen compounds are used at all construction joints. At the top of roof, about 60 centimeter thick earth layer is deposited and maintained green lawns to protect the reservoir from cold and hot. For aeration of water in inspection, ventilation pipes and strain stairs are provided. Elevated reservoir. Elevated storage reservoir ESR also referred as to overhead tank or required at distribution areas which are not governed and controlled by the gravity of distribution. These are rectangular, circular, or elliptical in shape. If the topography of the town not suitable, for under gravity, the elevated tank or reservoir are used. Elevated reservoir. They are constructed while combined gravity and pumping system of water distribution is adopted. These tanks may be steel or RCC. Now, RCC is commonly preferred. The accessories of elevated reservoir are inlet and outlet pipe, overflow pipe, discharging into a drain, float gauge, deciding depth of water, automatic device to stop pumping when the tank is full, a manhole and holder, and ladder, ventilator for circulation of fresh air. This is the elevated reservoir diagram. Total storage capacity of distribution reservoir is summation of balancing storage, the quantity of water required to be stored in the reservoir for exclusion or balancing fluctuating demand against constant supply is known as the balancing storage. Breakdown storage and fire storage. Analysis of complex pipe network. In next class, we see this continuation. Thank you.